This is the sky this month for most of December and a few days of January. And what do we have mostly? We have some interesting space station passes. It's not exactly deep sky astronomy, but it is interesting. For reasons I can't quite figure out or visualize, all of the passes, morning passes, and that's all we have until mid-January, seem to go by Venus. It has to do with orbital inclinations of the space station, the tilt of Earth's rotational axis, and other things. And like I say, I still don't get them. But they make for very interesting views. They all go right by Venus several times. And we have the Geminid meteors December 13th and 14th. Now, after the fact, we were clouded out, but why bring that up now? Jupiter is putting on quite a show with all the moons because it's just past opposition. And hence, it's about as close as it gets. The moons are nice and big and bright. And in case we miss the Geminids, well, we might have the same problem with the Quadrantids on January 4th. If memory serves, they can be pretty spectacular, but they're a very narrow peak of about 8 to 12 hours. So we got to pray for weather. Anyway, some of the space station passes. There we are. So, December 15th, these are screenshots from Stellarium. And at 7:15 in the morning, you can see the space station at the lower right of that screenshot, Venus at the upper left, and the Chinese space station, which is a very small, unbright dot. I don't know much about it. I haven't gone looking for it. However, certainly the space station and Venus are bright enough to see, even at that time in morning twilight. Next. At 7:17, there it is, going right by Venus. And on the next day, at 6:29, it does it again. I'm not sure why that is exactly, but it is interesting. It helps you find it, because you'd have to be blind to miss Venus in the southeast sky every morning. Next is the 17th. And yeah, there it is again. At 7:17 in the morning. And finally on the 19th, Venus space station and SL3 rocket booster. If you've never seen rocket boosters going by, check out Heavens Above, because they show passes for all of the naked eye visibility satellites. Rocket boosters quite frequently tumble, so you can watch them go blinking as they cross the sky, quickly or slowly. And on the 20th, with Venus just coming over the horizon at 4:52, I won't see it because it's against my religion to get up that early, but there's the space station again. Okay, enough space station. The Geminids, they're one of the most populous meteor showers, up to 100-ish per hour. That's their maximum. Now the radiant comes up just after sunset, and you can see it with no moon. This is a weird one, though. It doesn't appear to be a comet. It may be a dead comet, one that's completely degassed, but they're calling it a rock. It's an asteroid, but it's in an orbit that goes very close to the sun, about a third, 40% of its closest approach, perihelion, is about 40%, I think, of the mean orbital radius of Mercury. So when it goes by the sun, it gets really hot, like 1,000 degrees. And that may be enough to stress the surface and pop little bits loose. And the solar wind that close is strong enough to actually, because it doesn't have much gravity, to move bits off the surface of the rock. In which case, solar wind pressure and so forth spread it all out. And we go through that trail that it leaves behind every year. And that is taken from the former Arecibo Radio Observatory. And you can actually see the thing rotating there. That was taken in 2017. Next is, this is a neat little GIF I got, and it shows how close that asteroid goes to the sun. That little teal or turquoise inner circle is Mercury. So this thing's going quite a bit closer to the sun than Mercury, and it gets hot. So the thermal stresses may be enough to make it behave like a comet with stuff coming off it. Next. Okay, there's the radiant you can see on the left side, the Geminis. You can see Orion on the right-hand side, and the two stars on the left. The bottom one is Pollux, the top one is Castor, and right next to Castor is that little splodge that says Geminids. That's where they appear to radiate from. So it's actually in the northeast. And as a result, we get a better view of it in the northern hemisphere than they do in the south. Next, Jupiter's moons. Opposition was November 2nd. So these are about the best views you can get of it because we're as close as we can get. So here we are on December 9th at 2 a.m. And because the moons all orbit Jupiter, you can tell its orbital plane is tipped just a little bit to our line of sight, because the moons aren't all lined up strictly along the equator. And they're all very close in, as you can tell. Sometimes they're further out, but when they're all close in, this is what it looks like. Next, on the 11th. And that's the opposite. You've got Io right behind Jupiter, Callisto to the upper left, Ganymede to the lower right, and I'm not sure where Europa is. It may be behind the date-time label. Can't tell. But they do spread out. And here we are on the 29th with all four of them above and left of Jupiter. This is a screenshot of 2 in the morning on the 29th of December. And Io and Europa are side by each, at least visually. With Ganymede and Callisto, actually it looks like they're actually laid out in terms of their orbital radii. Io, Europa, Ganymede, and Callisto. And lastly, on January 4th, we get the Quadrantids. Now, I wish I'd shown it with a better screenshot. That spot that you see, the stars just above it are the free end of the handle of the Big Dipper, which is sort of balanced on the end of the handle with the dipper part straight up. And that's the easiest way to tell where the radiant is. And again, this is another one that you see much better in the northern hemisphere. That radiant is up all night. The moon comes up about 1 in the morning. But the night before, in other words, on the 3rd, we should be able to see them because the radiant's above the horizon. They come in from the north, and that's the side we're on. So it should be good. One other thing that I didn't manage to get into this presentation, because I was thinking month end to month end, on the 8th of January, you'll be able to see Mercury in the morning near Venus. It doesn't get as high as Venus and it isn't as bright, but it's a good morning apparition. From about the 1st to about the 15th, everything happens quickly with Mercury. So if you imagine, I believe this star here to the lower right of that Quadrantid's label is Antares, which is the bright star in Scorpio. And the interesting thing is, on the morning of the 8th of January, you'll be able to see Mercury just above the horizon, about 4 degrees up, Venus about 8 or 10, and a crescent moon, which of course is orbiting the Earth from west to east. So it's moving right to left with regards to the stars. And on the morning of the 8th, this happens before it rises. It crosses in front of Antares. But at 6:40, I believe, our time, if you've got a clear view to the east, southeast, you'll be able to see the moon uncover Antares. And it's the dark limb of the moon that does it. So you won't just sort of see it, the star, vanish behind a bright lunar crescent. No. It'll blink in as the moon moves to the left and down and unblocks it. And that's a little more spectacular than just watching it get covered up by a bright moon. So it's pretty spectacular. And that's January the 8th at about 6:40 in the morning from Seychelles. And that will basically wrap up the good stuff. Just thinking of naked eye and occasionally binocular astronomy. So that's it until the next go round. Our meeting, I believe, is the 12th of January, and there'll be a new one at that time. Thank you very much.